What's up guys, welcome to the software engineering channel. In today's video I'm going to be showing us how to perform a retrieval of a domain object that has a one-to-many relationship with another domain object using Dapper as our ORM in NetCore. Let's dive right in guys. So this video came up because I had this problem in the course of the week. I was working on an application and I was using Dapper, of course, Dapper ORM. And if you do not know what an ORM means, an ORM is basically an object relational mapper, and it's the idea of an ORM is to help you abstract the communication between your database layer and your application layer. So they are very complicated communication abstraction that your ORM does for you. So basically this is basically a monolithic setup. We have the API layer, we have the core layer, and we have the infrastructure layer. I'm not going to go into details of the setup. Is basically your clean architecture setup, but the idea of this tutorial is basically to teach you, to show you how to actually perform that retrieval of a particular domain that has a one-to-many relationship using Mapper. And in our case, we have products and we have product variation. Of course, you know, a particular product can have multiple product variation, right? So you can have a shoe, and the shoe can have black variation, white variation, silver variation. So a shoe has multiple variations. So that's the one-to-many relationship we're talking about. So I have my model set up already. I'll just walk you through my code before we dive right into writing the logic. The basic thing I really want to get out of here is actually that particular logic, because it was a pain for me to find it and solve that problem. So I'm going to make it easy for you guys or anyone who's going to solve that problem in the nearest future. So I have my product. My product has a product variation, which is basically just for the sake of navigation and populating my entity on retrieval. And I also have product variation. Product variation is the variation for a particular product, and it has the product ID, which is the foreign key, and it has also a navigation property. And yeah, I mean, these are your normal POCO class, so it's the one we use and love every day. And I also have my API layer. My API is basically my presentation layer, so I'm going to be using an API just so to make the whole tutorial slim and simple. And I have my infrastructure layer. My infrastructure layer is the layer that speaks to the outside world. That's where I have my brokers. Within my brokers, I have a repository. My broker is basically, the idea of a broker is anything that helps you speak to the outside world. And I have my repository. I can have my login in my broker. I can have an API wrapper, client wrapper in my broker, but all I need is my repository. And in my repository, I have my product repository. And you can see my product repository here. This is where we are going to be writing code for the retrieval of the product migration. I have my DTOs. I'm going to put a link to this particular code base so you can look through and play around it. So let's go into the major work for the day. So I'm going to go into my repository, and my high repository rather, and I want to define a contract. And the contract is, we want to be able to get a list. We want to be able to get a list of products. We're going to get I collection of products from our database. So we say get products. Simple. So we are going to call this guy in. Awesome. All right, so we have defined our contracts in our I repository, I product repository. So we can go into our product repository and implement that particular contract. Yeah, so if you take a look at my data folder, I already have my Dapper connection setup, my project connection setup here. So this guy is going to be my connection string setup from my application to my database. This is what Dapper is going to use to know how to communicate with your database. And I also have my context here as well. So let's go back to the repository, and I have to bring in my connection here. So I would say yt underscore Dapper connection. The assumption with this tutorial is that you're probably familiar with NetCore to a large extent, and that's why I'm not explaining certain concepts. For example, we are using dependency injection here to inject our DB connection into the repository. If you are not familiar with all of these concepts and you want me to go from scratch to teach build courses on NetCore or as regards to Dapper with NetCore or NetCore itself, just let me know in the comment section below. I'll use Visual Studio to initialize my connection. So I have my connection string. So I'm going to make this an async because it's going to be an asynchronous method. So the first thing you do, if you're familiar with Dapper, the first thing you do is to write your query. I'm going to be writing my query. You can use stored procedures as well with Dapper, but I'm going to be going via the query routes. I find that comfortable for me. So I'm going to be saying select products.id. I'm going to be using some alias here. Products dot let me put my product objects side by side so I can see all that I'm going to be selecting. Awesome. I'm just going to close this for now. So I have products.name. I have product.price. And you're going to be seeing the reason why we are using alias. I think it's just much simpler and easier. Yeah. Product dot is available. Product dot has variation. Product dot create arts. Yeah, so that's basically all that we are selecting. And we are going to be selecting all this from. And just to clarify, I also already have my database set up. As you can see, I have my products already in my database. I have my product variation as well already in my database. You notice that I've populated my products already. So if you check my products variation table, you can see all of the different variation we have for a particular product. So you see one same product has 3 variation. We have another product that has just 1 variation. And as well, if you check my products listings, you would see that I have 2 products. So the idea is we want to get all of these 3 products, including their variation. That's basically what we're trying to achieve here. So we're going to be getting this from to a DBO dot products. I'm going to be saying this is as prod. So we are going to be doing a left join with DBO products variations as prod var. So let's just say variation just to make it clear. Variation and we're going to be doing that on. So what key are we going to be doing that on? We're going to be doing that on our product ID. And if you check our products variation, you will notice that we also have a product ID which serves as our foreign key, with our product model. So that's what we're going to be using here. So we're going to be saying on prod.id, take this to the other line, equals prod. I'm just going to use prod var for the sake of spacing. Prod var dot product ID. Awesome. So this is not all. Now what we specified here is all of the things we want to get, but you notice that all of this is only the information on our product table. We also want to include information on the product variation table as well, right? So we have to do a select on that table as well. So we're going to put this at the other side just so we can see the item we want to select. So we're just going to append a comma here and say, so since we already have an alias for this particular table already, so we can use that alias to say prod var. We want to select its ID as well. We want to select the title. We want to select the value. We want to select the price. We want to select the created dates. That will be all. That'll be all. Okay, so this is our query, and normally if you're familiar with SQL, what this is basically going to do for you is it's going to select all of the information on your product table, right? It's going to select all of the information on your product table, and it's going to select the matching column, only the matching column on the left, which is your product variation table. And so you would have all of the information on your product table, and for any product that doesn't have any matching column, it's just going to be filled with null, but it's going to select all from your left, which is your product table. That's how left join works, right? For inner join, is basically not going to select anything in the product table that does not have a matching column in the other table. But for left join, it's going to select all on the left and map it with the right. Whichever product that does not have a variation is just going to be nullified. So that's how left join works, and that's what this query is going to be doing for us. But the difference between Dapper and Entity Framework Core is basically that in Entity Framework Core, you would have used .include. .include is the extension method that does the wrapping, all of the mapping of the object and everything we are going to be doing now. In Entity Framework Core, all you just need to do is to do .include. But I mean, that's the concept of a micro, very slim ORM, is that you do all of those things by yourself. We are now basically going to be writing the logic that helps us appropriately perform the mapping between the query results and our domain objects. That's what we're going to be doing. So we're going to be creating a dictionary here. This dictionary is basically going to serve as is going to serve as you want to see it as a store, kind of. It's going to serve as a store for us. So we have int and we have products. So it's going to hold a key value, which key is going to be an integer, and the value is going to be a product. So we're going to say let's use our connection. We basically want to open a connection. That's how Dapper works. We open a connection, say this.db.connection. We can close up these guys so we can have large space. Create a connection, and of course the reason why we are using this using keyword is just so that it can help us dispose all resources when we are done with the connection. So yeah, let's have an high enumerable products. And the reason why we are using high enumerable here is because Dapper would always return an high enumerable type when you're getting a list of products. Dapper would not return high collection. Dapper would always return high enumerable. I might be wrong. There might be some settings that would allow for Dapper to return high collection, but up until now I'm not aware of that. I'll probably do deep research, but I mean, if you are aware of that, I mean, you can point it to me in the comment section below. But up until now, I know Dapper would usually return high enumerable for multiple objects. So let's do an await db connection, and we'll do a query async. It's basically an asynchronous query. And now this is where the juice lies. So we have our product, we have our product variation. So what Dapper is trying to do is Dapper is asking for all of this type so that it can basically understand how it's going to go about mapping those objects. So you see that our query async takes a number of arguments. So the first argument we are going to pass is our query. Let's bring in our product variation. Oh, that's wrong. Set product variation. Let's bring in Dapper as well. So you notice that our query async takes multiple arguments rather, and it's an overloaded method. So the first thing we are going to be passing is our query, and we are going to be passing a function basically, which is what's it called now, which is an anonymous function basically, to perform the mapping. So we have products and we have product variation. If you are used to writing JavaScript, you would understand what something like this does. It's basically an anonymous function. In JavaScript, it is called an arrow function. So that's what we're trying to do here. Okay, so let's have a product line around. Now, the first thing we want to do is to check if is to check if the product, because this is like it's a map function basically, so it is going to be running through all of the rows that Dapper returns from our left join. So what we're trying to do now, the first thing we want to do is to check if that particular row that is returned is contained in our dictionary. So we'll do a try get value. And the reason why we are doing a try get value is just so that we don't get an exception if it's not in the dictionary. So we're going to say check if there is an ID, product ID, and if there is, we are going to use this out keyword to get that particular product. Okay, so let's use we need to use another name just so .NET is not confused. So let's say prod here, and let's use products for this. So what this is going to do is basically going to check if there is any key, of this particular product inside of the product dictionary. If that is the case, it is going to send out the value, and of course you've seen from here that the value is actually the product itself. It's going to send out the value to this particular guy over here, hence the reason for this out keyword. Okay, so but if that is not the case, which is the reason for this not, if that is not the case, the first thing we are going to do is we are going to say our product will be equals to our prod, which is obviously the first iteration, and we are going to say our product dot product variations will be equals to a new list. So what we're trying to do is just to initialize a list of product variations. So we say product variations, because at the end of the day, the idea is that we have a product that has a list of product variation, hence the one-to-many relationship. So we're going to say product dictionary dot add. So we want to add that particular product to the product dictionary so that when it's repeating this logic again, it can flag it that we already have it in. It's not going to have to do this, and we are not going to have multiple repetition of the same object. Because if you know how left join works, you would notice that there would be repetitions of that same product, right? So and the idea is we don't want to have repetition. We want to have just one of that product, but the repetition of its product variation is what we need. So we have product. So we are adding the ID and the product into the dictionary, right? So we don't have that repetition. So now what we want to do is we want to do a check. We are going to do a check on the products variation. Products var. We're going to do a check on the product ID, because we do not want to pass a product variation that actually that is not mapped to a particular product. So if it is greater than 0, that means obviously it's mapped to a particular product. So it will be 1, 2, depending on what the ID of the product is. But if it is 0 or anything less than 0, it's actually it's going to be 0 if it's not mapped to a particular product. So that's what we're trying to check here. So if it's greater than 0, what we want to do is to take that product and get the product variation that is attached to that product, and we're going to add that product variation. And don't forget that we already made our product variation a list, hence the reason why we have that add method to be used. And when this is done, we are going to return products. Now the other parameter you want to use here is what we call split on. So what split on is basically going to do, according to documentation, it says the field we should split and read the second objects from. So it's more like the concept of join, right? But the idea here is Dapper wants to be able to understand what key to be used as a reference for the mapping of both objects. That's what Dapper is asking for. And in our case, what we want Dapper to use is the product var.id, which is basically the ID of the second table. So it would usually be the ID of the domain that has the many relationship. That's what you usually use on the slip on parameter. So we are going to pass this in a string ID. Now the reason why we would have to use prod var ID is because obviously you can't say prod var.id, right? So we would say prod var ID, and then we would go back to our query and form an alias, right? So we'll form an alias of that same name that we're using. So we'll just say take this prod var.id and form an alias of it and name the alias prod var ID, right? So it is this alias that we're going to pass to our split parameter. Now we're done with that. So what we're going to do next is to say products would be equals to the results, whatever results we've gotten from here, and we want to select distinct. All right, so we want to select the distinct. We want to have a distinct list because if you know how left join works again, you would notice that we're going to have repetitions, right? Hence the reason why we're selecting a distinct list using the distinct keyword. And this is coming from link. I'm sure we're aware of that. It's coming from link, and we want to make it a list, and then we can do a return on our products. That's basically all. That's basically how it's going to work. All right, so having done this, the next thing we want to do is to basically go to our service. I already have my service interface here, and I've defined what I want already. The prod for read is basically a DTO that exposes our product domain objects. I mean, you don't want to expose your domain objects directly to users online, right? Or to your consumers, whatever that means to you. Basically, you do not want to expose that, especially when you have some methods or some properties rather. For example, if you check our products, if you check the product class, you would notice that we have this is available property. So normally we do not want to expose this particular property because a user should not be able to tamper with this is available. Hence the reason why we're using a DTO. So it's a good practice. It's always a good practice to use a data transfer object. And that's what we're using. I mean, it's a software engineering channel, so we have to use good standards here, and that's essence for all of this. Otherwise, I would have just put on something very dirty, and as long as you get the idea, but we're passing the ethics along. So we're in our service, and we have implemented our. So let's inject our repository. So we can say iProduct repository. Can say iProduct repository. Let's have that and we can say product repository. So let's initialize that. So here we can easily say var products would be equals to, let's introduce our sync, be equals to await this dot products repository dot get products. Simple as that. And we'll return our products. Now this is not going to work obviously because this is expecting prod for read and we have products. So what we want to use is we want to map our product to our product for read, and we're going to be using AutoMapper to do that. iMapper rather. AutoMapper is a very interesting nugget package that helps you do all things mapping. If you do not understand how all of this works, as I said, this is not for a beginner. If you do not understand how all of this works, just let me know in the comment section below so I can start to prepare a beginner type of course for this particular tutorial. So we can do a beginner.net basically. So what we want to do here is to actually do a map, and would say products for read would be this dot map my collection products for read, and would add our products as our products, and we can now return our products for read, and we are fine. .NET is happy as well. So basically we are using AutoMapper to map our products with our products for read, and it's an I collection, so we have that in our products for read, and AutoMapper and .NET is fine with that. Of course, to use your AutoMapper, you would have defined your profile, which is something I've done. You'd have defined your profile, your mapping profile. So you'd see here that I already defined a profile. We are mapping from source, which is products, to destination, which is products for read. Hope that makes sense. So let's go to our controller to expose our API. So it's going to be an async method as well. So we'll have async, we'll make this a task, so we're simply going to say var products. Let's bring in our service. Let's bring in our product service. So we say I product service, product service, and we can use dependency injection, which is what we're using actually. So we can say await these dot product service dot retrieve products, and we're going to do a return okay on products. Now, I mean, guys, all of this does not cater for exception handling and all of those things. I don't want to add all of those stuffs into these projects just so that we don't make the whole thing lengthy. But of course, exception handling is a thing you want to do. I mean, it's not going to always be sweet, right? You might have some issues which, I mean, we might fall into one. But so let's run our projects and hopefully we have the whole thing working. And while the project is running, is building, let me also show you and inform you that I already defined added our dependency injection configuration here. I did that for our repository, I did that for our service, and I also did that for AutoMapper as well. I already did that, all of those here. And basically this is Swagger configuration which comes along with your project. So let's wait for our project to build and run. So let me know in the comment section below if you want me to make a full video from scratch actually, or a project that has to do with Dapper from scratch, just so I can teach you all of the concept of how I structure my project and have a very nice maintainable setup. So I got an error, guys, and basically the error is saying I have not the project is unable to resolve our connection, and I think this is because we did not add a connection to the DI container. So we're going to do that now. So you can say services dot add scope and what's the name of our connection? YT underscore Dapper connection, if I'm not wrong. Let's bring that in. Awesome. So let's run that again. Awesome. So we have our API up already, and let's test our API. It executes. And hope it works. Let's see what's happening. Okay, so it worked, but it did not populate our variation. So let's go back. The first thing I do is to try to run my query to see if I'm missing anything at all. Let's create a new query. Let's select all. So our query runs well, and this is the result of our left join. But also notice that there is no product ID here. But if we check our code, we are referencing product ID here. That's one. Yeah, SQL isn't going to complain, but surely Dapper is going to have issues when it starts mapping. So let's add that product ID. And let's also look through this as well. So this is a mistake. We are not supposed to. This is supposed to be prod. So we're supposed to be adding the ID of this guy to the dictionary. Although that shouldn't be a problem because we are assigning this to this already. So yeah, anyone should work. But yeah, I think changing this would give us success. So let's do auth reload, and let's go back and do a run again. Yep, and it works now. So you can see our products, one product, Dapper Nike, and it has 3 variations. It has the white variation, it has the black variation, it has the silver variation. We have a water bottle, that's a size variation, and we have a Y-phone X6, does not have any variation, and that's exactly what we have in our database. And this is exactly how to do a one-to-many retrieval using Dapper in .NetCore. So that's it, guys. This is how you retrieve a one-to-many objects, the main objects, using Dapper in .NetCore. I hope you enjoyed this video. Give it a thumbs up if it makes sense to you, if it has helped you, and don't forget to hit the subscribe button to get videos like this. See you in the next video, guys. Bye bye.